as you might know, the 7th through 10th were challenged to work with the little kids to create a little thing called stomp rockets, which are small rockets made out of paper that you can stomp on soda bottles to launch. The first step was to get together with my team members and discuss how to build the rocket. So I went over it briefly. I briefly explained them that process and we got to work. At first, we just wanted a regular rocket with nose cones and a set of fins, but as we progressed, Remy made a good suggestion that we do 2 sets of fins, one smaller than the other. I agreed and thought it'd be a good idea because it also helped to be a test subject and begs the question, will our rocket fly better or worse with 2 sets of fins of different sizes instead of the traditional 2, 3, or 4 fins? After knowing that, we got to building. I assigned roles, with Zula being the co-builder, Holly being the video recorder, and Remy being the main builder. We started off by making the body, which I had Remy do. Then, Zula got to work on the nose cone, and finally we finished by making the fins. Throughout the process, we also decided to get our predictions on how high we think it'd go. Everyone else's predictions were around 5 to 7 feet, while mine was around 15 feet high, though later you'll see we vastly underestimated the power of our rocket. Moving on though, this was our beautiful first final design, named the C.N.H.R. space shuttle. Today was the day of the first launch, so you can see just how high our rocket goes. Multiple questions are begging to be answered here. How high will the rocket fly? Will it succeed at all? Will it go straight up or perhaps curve and gain some unpredicted distance? All these are good questions that will get answered with this test. Unfortunately, I wasn't here for this day, so thankfully Levi took over for me. He began setting it up by showing the younger kids how to use height recording devices, which are the devices we use to record our rocket's height. He told them the proper instructions of launching the rocket, as you cannot step on the bottle parallel because it will damage it, so you have to step perpendicular, and more things. After he was done setting all that up, he ran some tests.
Go!
To him, it was surprising how high the rocket actually went, and looking at the footage, it surprised me too. You don't expect a stomp rocket made from paper to truly succeed so much and gain so much height, but if done correctly, the results do shock you. With the first launch being completed and turning out to be a success, we had to gather the data points for the math. The math was pretty straightforward. Our final vertical distance, which turned out to be 31.6 meters. Compared to our first predictions of a couple feet or 15 feet, I'd say we were quite a bit off and not expecting that at all. However, it was great to see the results were so positive. So we came together once again days later and discussed to get ready to build our second iteration. On the 18th, our team got together once again to sit down and discuss what went well, what shocked us, what we could have done better, how we felt about the first launch, and finally, what can we do to improve our rocket. Overall, everyone was quite content with how the launch went and the distance we got, though we felt it could have always gone better. We came to the conclusion that we should shorten the rocket to possibly reduce weight, keep our fins traditional instead of making them 2 different sets, and reinforce the nose cone so it doesn't pop off and to add sturdiness. After that was all done and dealt with, we knew what we had to do and began building. We did the same things as before, rolled up the paper not too loosely or too tightly, then made the nose cones. Though this time around we made 2 nose cones, one to go on the inside and the other to go on the outside. That way there will be less chance of air escaping and it'll act as a reinforcement, which Holly suggested. We attached the nose cones to the rocket, and then this next step was to shorten the rocket, which was Remy's suggestion. Then lastly, Holly created the fins for us to place on the rocket. This time around we only used 3 that were all congruent. We then went out to finally test our last iteration of our rocket. This time we would be looking for improvements in height to answer the question, do more fins help with drag and distance, or does it worsen it and throw it off course? And does shortening the rocket help with distance as well? Along with the final question, will our nose cone reinforcement work this time around? With all those questions in mind, we first decided to get some predictions in. So starting with this new rocket, how high do you think it's gonna go?
Slightly higher than we originally had it.
You think it's gonna go still straight or like maybe backwards, forwards?
Depends who's launching it.
Who's launching? Okay.
I think it might go a bit higher than we used our other rocket with, and I think it won't go straight. Maybe a farther distance, but not that high.
Not that high? Straight up or back or anything? Or just completely straight up?
I don't know.
Okay. After all the predictions were done and dealt with, it was time to launch. We did a couple different launches to be able to get accurate data points. Honestly, this set of launches went a lot smoother than last time, and it cut through the wind so easily and beautifully. Regardless, we got great data and video, and it was time to see if our rocket improved. In the end, doing the math, our rocket got a whopping 42.615 meters as our final vertical distance average, which clearly showed improvement. This entire project was great. Getting to work with the younger kids, teach them what we learn also, learning how to analyze data and work as a team, and so much more. I'm very glad we were able to do this, and this taught me a lot and was a great representation of STEAM, which is science, technology, engineering, art, and math. To me, STEAM means observing and being able to discover our world with things like the scientific process, being able to use technology as a tool to help achieve things we may be curious about and want to test, creating and developing new things as a way to expand ourselves in our imagination, getting creative and expressing, conveying emotions with art, and being able to calculate outcomes or mathematical parts of an experiment like we did for this project. Overall, it was amazing, and I would definitely do it again to see how much more I could improve.